Here's our first video on section 2.3. 2.3 is all about getting solutions of systems of equations, like these ones where you have two variables and two equations, but using algebra methods instead of just graphing to use the graph to find which point is on both lines. So this first method we're going to do, you've hopefully seen this before in beginning algebra, but here is an overview of it. And we're going to do this with this first example, solving this with substitution. And remember, always pause it whenever you need to copy down stuff, or try to work things on your own, or read things ahead. But for right now, we're going to look at step 1, which says choose one of the variables in one of the equations. And we'll choose one whose coefficient is 1 or negative 1. So that one that we've chosen right here is going to be this x. And then we're going to solve the equation for that variable. So that means solve for this x means get that x on one side by itself. So to do that, let's start by adding 4y to both sides of that equation. And that will give us the equation x equals 15 plus 4y. So that is step 1. Now step 2 says substitute the result of step 1 into the other equation. This gives you an equation in one variable. And this is the real substitution step here. The important thing is that if we're talking about a value of x that makes both of these equations true, then it needs to be the same x in the second equation as in the first equation. So we're going to take this value of x that we have here, which is supposed to be 15 plus 4y. Whoops. We're going to take that expression for x, that must still be equal to the x in the other equation. And that's what the real substitution is replacing this x with 15 plus 4y. And this is what that will look like. And the reason why this is nice is it results in an equation that only has y in it. And that means you can just solve it the regular way. Get y by itself on one side, and the other side is going to be a number. And this way we've combined both of the equations into one, and we can find the value of y that makes both of these values of x the same, is the idea. So now let's solve that equation. That's step 3 here. I'm going to start by distributing the 3 into this. So 3 times 15 is 45. 3 times 4y becomes 12y. And it looks like that now. We can combine the 12y plus 2y into 14y. Then we can subtract 45 from both sides of the equation. And that'll give you 14y equals negative 28. And then when you divide both sides by 14, that gives you y equals negative 2. Okay, so that was step 3. We now know that if y is negative 2, that will solve this equation from step 2. But then we need to, if we're trying to solve the whole system, we also need to know what x is. So that's what step 4 says. Substitute this value into the result of step 1 here in order to find the value of the other variable. So that means we know that y is going to be negative 2. You can find what x is by plugging in that negative 2 in place of the y from this equation, and that gives you x equals 15 minus 8, which is 7. So now it looks like we found a solution of the system. It's always a good idea to check that this is actually the solution by plugging it in. So when you plug in x equals 7 and y equals -2 into it, is 3 times 7 plus 2 times -2 equal to 17? It is if you work it out. And if you do 3 minus 4 times -2, that will become 7 plus 8, which is 15. So that works with both equations. This is really the solution. 7, -2. Now here is an exercise for you to do. You're going to solve this system by substitution. It's a lot like the one I just showed you how to do, so you might need to go back to get help. Or also, if you're in the CAS, then hopefully you can get help that way too. Good luck with that, and we are going to have a few more videos on section 2.3, so you'll hear me again in the next video.